Well, my problem says find the exact value of sine theta, cos theta, and tan theta for theta is equal to pi on 12. Okay. Well, the angles that I know the exact values of sine theta and cos theta and tan theta for are the small fractions of pi. So a half of pi, a third of pi, a quarter of pi, and a sixth of pi. And this pi on 12 is even smaller than them, so I don't know what it is already. But there are formulas that allow me to figure out what sine and cos and tan are for angles that are combinations like plus and minus and 2 times things. So maybe I can find a way of adding or subtracting these angles together to get a pi on 12. Well, a 12 on the denominator would happen if I did something by adding thirds and quarters, because you have to make a common denominator, which would be 12. And a third and a quarter are pretty close together. Let's give it a go, just a second. A third minus a quarter. The third would be 4/12, and the quarter would be 3/12, which is a 12th. Okay, so pi on 12 is going to be a third of pi minus a quarter of pi, which means that we can use the addition and subtraction formulas to figure it out. So let's see, sine of pi on 12 is sine of a third of pi minus a quarter of pi, which would be sine of a third of pi, sine, no, just a second. The sine puts the sines and coses together. Cos of a quarter of pi minus cos of a third of pi, sine of a quarter of pi. Okay, so I'm going to need to know what those things are. A third of pi happens in the one that's half an equilateral triangle. So that's a third of pi there, 60 degrees. And it'd be 1 here and 2 here and √3 here, but I'll just have to divide by 2. So that's cos of third of pi, that's sine of a third of pi. And I'm going to need cos of pi on 4 as well. It's half a square, 1, 1, and then √2. And I'll just divide by √2 and I'll have it. Okay, so sine of pi on 12 is now sine of a third of pi, which is √3 on 2, cos of a quarter of pi, which is 1 on √2, minus cos of a third of pi, which is a half, times sine of a quarter of pi, which is 1 on √2. And so they've both got a 2 on √2 on the bottom, and the top is √3 and 1. Okay. I reckon I'll just need more space for that. Cos of pi on 12 would be cos of a third of pi minus a quarter of pi. Now the cos formulas put the coses with the coses and the sines with the sines. Sine. And they turn minuses into pluses and pluses into minuses. Okay. Okay, cool. So all right. So I know what all these things are from my triangles earlier. A cos of a third of pi is this one, a half. Cos of a quarter of pi is 1 on √2. Sine of a third of pi is the opposite, which is √3 on 2. Sine of a quarter of pi is 1 on √2. And again, it's still got 2 on √2 on the bottom. And we've got a 1 and a √3 on the top. Okay. So tan of pi on 12 is the slope, and the y is the sine, and the x is the cos, so it should be sine divided by cos. Which will be 1 root 3 minus 1 onto root 2 divided by root 3, that's not a 2, 1 plus root 3 over 2 root 2. And the 2 root 2's, if I multiply top and bottom by 2 root 2, then they'll go away. Cool. Okay, I just feel a need to check that. I'm just going to get my calculator. So let's see, is it in radians? Yes, okay. So sine of pi divided by 12 is 0.2588. And square root of 3 minus 1 divided by 2 times square root of 2 is 0.2588. Okay, it's looking pretty good. Cos of pi on 12 is 0.9659. And 1 plus the square root of 3, no, plus 1 plus the square root of 3 divided by 2 times root 2 is the same answer. Okay, so the tan should be correct then, but I'll just check it. Tan of pi divided by 12, 2679, and square root of 3 minus 1 divided by square root of 3 plus 1, 2679. Okay, well, I think that they must be pretty good for the exact answers.